Hi everyone, this video is for, I need to zoom out a little bit here. This is the second video for section 9.3. Go ahead and copy that part and I'll just explain it a little. So over here, you can see there's a circle overlaid on the coordinate grid and there's an angle drawn, just like we've been drawing the angles. Remember, they always start here on the x-axis. This would be a positive angle. And what we have here is a coordinate point, only this time it's on the coordinate grid. So in the last section, we had a coordinate point, and same kind of idea for this section, except for the unit circle, the radius is always going to be 1. So this side, this distance here, which would end up to be our hypotenuse, is always going to be 1. So this circle that we overlay here with a radius of 1, the center of that circle is right at the origin of the coordinate plane. So let's look at this. This is just like what we did in the first part, except for this problem, our r is always going to be 1. Whereas in the first part of 9.3, we calculated the r. Remember, we used this formula? Well, now for unit circle, r is always 1. So we're still going to use that y over r, x over r, y over x, like we did in the first part. But this time, the r is always going to be 1. Okay, now all of these for example 1 are going to be 90 degrees. So you can think, well, 90 degrees, if I start here and I rotate up to there, here's the terminal side, here's my 90-degree angle. So I'm right here on the coordinate grid. Well, if from the origin over to the circle here, this is the radius of the circle, if that equals 1, then you can think about if I plot this point, I've gone over 1 and I've gone up 0. If I plot this point, I've gone over 0 and up 1. I could fill in these other ones right now also. This would be over -1 up 0. That would be for 180 degrees. And this would be over 0 down -1. That would be for 270 degrees. So for this example, we're just looking at the 90 degrees. So this is our coordinate point. That's our x, that's our y for a 90 degree. So y is 1. Radius is always going to be 1. 1 divided by 1 is 1. X is 0. R is 1. 0 divided by 1 is 0. Y is 1. X is 0. Now this, if you put that in your calculator, you're going to get an error because we do not divide by 0. So the tangent of 90 degrees, we say, is undefined. You could even abbreviate that UD. Okay. Now the partners, we're just going to take the reciprocal. Well, the reciprocal of 1 over 1 is still 1. The reciprocal of 0 over 1 would be 1 over 0, so that would make this undefined because I have that divide by 0 happening again. Reciprocal of this would be 0 over 1. That's no longer undefined. If you put that in the calculator, you're just going to get 0. Okay, example 2 is the same idea, but we're doing 180 degrees. So again, 180 degrees would be halfway around the circle. So I'm right here at this coordinate point, -1, 0. So this is my x, this is my y. It is on the unit circle, so that means my r is 1. So y over r would be 0 over 1, which would equal 0. x over r for my cosine is x over r would be negative 1 over 1, which would just be negative 1. And tangent is y over x, which would be 0 over negative 1, which would be 0. This is its partner, flip it. I end up with a 0 on the bottom, which I don't like to say equals, because it doesn't equal anything because it's undefined. Flip this fraction, well, you're just going to get 1 over negative 1. You're still going to have negative 1. Flip this fraction, you're going to have negative 1 over 0, again, undefined. Okay? Now, we can do that same thing for many different angles on the unit circle. So we're going to say, well, recall this, cosine is x over r, sine is y over r. If r is 1, then cosine is always going to be your x value, and sine is always going to be your y value. See if I can get a little better picture there for you. So if I'm doing unit circle angles, cosine is always the x, sine is always the y. Remember, I can always find tangent by doing y over x. And the other trig functions I can find by taking the reciprocal of whatever I get for sine and cosine. So this is the unit circle. I am not going to show you how to fill this whole thing in this video because the video would be extremely long. But I'm going to show you where these values come from. So from here to here is 30 degrees. So I could sketch a triangle on here. And if you remember, a 30, 60, 90 were those special right triangles that we looked at earlier. In those triangles, we said the short leg was 1/2 and the long leg was square root of 3 over 2. So to get to this coordinate point, I go over square root of 3 over 2 and up 1/2. So the cosine, and remember, x is cosine, y is sine. So the cosine of 30 degrees is square root of 3 over 2. The sine of 30 degrees is 1/2. So what I encourage you to do is to look up the unit circle online and fill this in, or I will put this in here. You could pause the video and fill in your unit circle. So you'll notice 30 degrees, 60 degrees, 45. These are angles that all came from those special right triangles, a 30, 60, 90 special right triangle and a 45, 45, 90 triangle. These are also, so these are my coordinate points for all of these different angles. And we have them written in degrees and radians. So this is all over the internet, but again, you could pause the video right here and go ahead and fill in your unit circle. And then I am going to have you turn the page, and I'm going to show you how we use the unit circle to find some of these angles. So I'll start with A here. I'm probably not going to do all these in this video. So the sine of 35 degrees, well, you should be thinking to yourself, 35 degrees, if I start here, I'm going to go past 90. I'm not going to go all the way to 180. So it's going to be about there, right? So that's 135 degrees. Now, I want you to look at your unit circle. Here is 135 degrees, so I've drawn it pretty good. Here are the coordinate points that go with 135 degrees. So I know the cosine of 135 is negative square root of 2 over 2, and the sine of 135 is positive square root of 2 over 2. So I'm going to put these coordinate points right on here. So they're asking me for the sine. Well, remind yourself that x is always the cosine, y is always the sine, So if they're asking me for the sine, I want the y value. So that equals square root of 2 over 2. Let's look at another one. 270. 270 degrees is if I start here and I go all the way around to there. So that's 270 degrees. So if you look on your unit circle, here's 270 degrees. It's right at the bottom, and the coordinate point is 0, -1. So I'm just going to put that coordinate point on there. So this is my cosine. This is my sine, x and y, cosine, sine. So the cosine of 270 is 0. Kind of getting the hang of this. Let's do this one, and then I'm going to do a -1. So 225. So this is 90, 180. This is 270. So 225 is going to be about there. 225 on my unit circle is right here. So it's 180 plus 45 degrees more. So there's my coordinate point, square root of 2 over 2. They're both negative because we're in quadrant 3. So this is negative square root of 2 over 2, comma, negative square root of 2 over 2. So the sine and the cosine are the same. So I'm just going to put negative square root of 2 over 2 up here because sine and cosine are the same. Now I want to give you a -1 before I end this video. So this is negative 240. Here's how I recommend you do these. Go to your unit circle. Well, and you can also, well, let's do it on the unit circle. Go to your unit circle and find positive 240. Here's positive 240. So if I start here on the x-axis and I draw a positive angle, I'm going to go halfway around the unit circle, excuse me, and then 1, 2, 3 more. That's actually 60 degrees more. So 180 plus 60 is 240. So that would be positive 240. I want to do negative 240. So I'm going to start here. I'm going to go in the negative direction 180, and then 1, 2, 3, or 60 degrees more. I end up right here. So negative 240 and 120 are coterminal angles. So let's draw this. Negative 240. I ended up over here. So that's negative 240. And I ended up on the unit circle at 120. So let me show you. If I take negative 240, let me clear this, and I add 360 to it. Remember how we found coterminal angles? Let me add 360 though. I get 120. So that tells me that negative 240 and 120 have the same sine and cosine because they are coterminal. So that coordinate point is negative 1/2, comma, square root of 3 over 2. So the sine, remember sine is y, is going to be square root of 3 over 2. So for negative angles, you want to find the coterminal angle on the unit circle that's positive. So I won't do this one completely, but I'll show you how it goes. Here's positive 30 degrees. I want to go negative 30 degrees, which would be right here. So 330 and negative 30 are coterminal. So these two values here are going to be my cosine and sine for negative 30 or 330. Let's look at one more. What happens when it's bigger than 360? Well, let's just keep minusing 360 degrees until we get a value that's on the unit circle. So I'm just going to take 450 minus 360, and I get, 90 degrees. So 450 is coterminal with 90 degrees. So for 450, I go all the way around and then I go back up to 90 degrees. So I'm here. The coordinate point here is 0, 1. Cosine sine, so the sine of 450 is the same as the sine of 90, and it is 1. Okay, that is it for our second video.